in the 304, it becomes 316. Moly is a good layer for the pitting corrosion. So when you are adding for the pitting resistance in the 304, it becomes 316 material. Okay, when you are again adding some more moly, it becomes a 317 material. So 316, if I'm not wrong, the moly percentage goes up to 2.3 or 2 percentage. Suppose you are adding some titanium. Titanium is good for the sensitization of any material. So it reduces the sensitization. So it becomes 321. If suppose you are adding the copper, titanium, and other nickel alloy, it becomes the participation hardening stainless steel. Likewise, if suppose you are reducing some carbon in the 316, it becomes 304, 316, 317 Al. So wherever you will find L, L means low carbon, means you have to reduce the carbon in the stainless steel. Understand? Okay. Suppose you are adding more moly and nickel and nitrogen for the corrosion resistance, it becomes a super austenitic steel. Super austenitic steel having a better for the corrosion. Likewise, suppose you are adding some chromium and nickel, it becomes 309 material. Okay. In the previous slide, I talked about the moly, addition. Now I'm talking about the nickel and chromium addition. So it becomes 309. If you are adding some niobium, niobium is also very good for the sensitization, or tantalum. So it becomes 347 material. Okay. So this is how you understand about effect of different alloying adding material in the different alloy. Now, in the coming few slides, you will good understanding about the effect of alloying element in the parent material. Suppose you are adding a magnesium. So what will happen? It increases the strain, toughness, hardenability. Okay. If you are adding a chromium, it will increase the heat treatment process. It also increases the hardness and strength. If you are adding a nickel, if you suppose nickel is added more than 8%, it will have for the high temperature. If it is less than 3.5%, it will be a low temperature. But it is good for the corrosion resistance. Moly is very good for the pitting resistance. Do remember about this moly molybdenum. And silicon is used for the deoxidation. Oxygen is very bad for the corrosion. So this is also a good material for deoxidation agent in the melting of steel. Titanium. Titanium is very, very costly material, but it is good carbide stabilization. So the term carbide stabilization, when I'm talking about, means it helps to make a carbide formation with the help of titanium. So it will not make a carbide formation with the chromium or moly. Okay. So the layer will be not depleted from the material, and corrosion will not going to affect that material. So you must understand about the stabilization and terms. Okay. Niobium, it is also a stabilizing layer. Here, you will not find in any of the book or any of the slides. This is developed by us based on the different material science, metallurgy, and different experiences. So this gives how the hardness, the strain, yield point, elongation is increasing or decreasing if you are going to add any material. In the first column, you see the different material. In the different column, you see the property of the material. Okay. So suppose I take an example. If chromium we are adding, so what is the effect? Hardness is going to increase. If suppose there is one arrow, means increase. If it is two arrow, means little more increase. So number of arrow indicate the intensity and intensity of the increase in the property. So take a picture of this and learn about effect of alloying material. Likewise, this is also a same. You can take a picture of this. You will understand what happens if carbon is adding and chromium is adding and nickel is adding in the material. Now, stainless steel. Stainless steel is quite increasing use worldwide. Everywhere, this material gaining the popularity. Because of the resistance to the corrosion, this material is widely used. What is happening is that the chromium oxide is making a layer, and it helps for the corrosion resistance of using it. So, stainless steel is further classified like a ferritic steel, austenitic, metallistic, and DSS. DSS means duplex stainless steel. So, one term that while you're studying, you will come to know PREN number. That is called pitting resistant equivalent number. So this is two formula. You can determine the PRN number. If PRN number is more, means it has a good resistance to the pitting. So more PRN number means good material for the resistance. In our industry, we generally recommend to use if the PRN number is more than 32. And suppose if you are dealing with S2S service, SO service, or seawater service, so we recommend to use PRN number more than 40. So ferritic steel. Ferritic steel, how it looks, it is a magnetic, it is a non-hardenable heat-treated material, and it is a BCC structure, coarse grain structure. Austenitic is a fine grain structure, it is FCC, okay? And it is non-magnetic. Ferritic was magnetic and austenitic is non-magnetic. Metallistic is basically a corrosion resistant material, but it is a high hardness. Okay. Precipitation hardened material means going to heat and cool down in the material. It is a magnetic one. Duplex. Suppose the structure of material is austenitic and ferritic in microstructure style, then it is called a duplex stainless steel. Duplex stainless steel is quite costly material, but it is very innovative and very good material which is being used in every industry. So it is good for the chloride stress cracking and good resistance to the corrosion and high strength. Its strength is almost 1.8 to 2 times than the stainless steel. Okay, fine. This is called USN number. Why it is important? How you are going to know that which is ferritic and metallistic steel? If suppose the grade or the series of the material is 400 series, just strike in your mind that it is a straight chrome steel, means ferritic and metallistic. If it is 300 series, means it is an austenitic structure. If it is a duplex, generally it is having 4 series, starting with 2 or 3. Okay. So this is same thing in a tabular form. What I had explained you. Austenitic is a very good in the availability, and it is a non-magnetic. Ferritic is a magnetic, but it is not good in the weldability. So we are not using this ferritic in the industry. We are using austenitic or duplex. Now these are some typical ferritic material, austenitic and other material, and typical percentage of chromium, moly and nitrogen. And its PRN number is given, okay? So just take a photograph of this. Similarly like this, okay? So generally in the industry, when we are talking about the lean DSS, means its PRE number is 26, okay? If we are talking about the recent development, even hyper DSS goes up to 49. Super DSS is 40. So these are some physical property also, hardness number, ultimate tensile strength, yield strength. So you can take a photo. In the ASME code section 8, section 2 part D, the physical property are given. ये better है ना? This material selection guide is one of the widely used book of Badner. So in the Badner, they had segregated it different form of material like plate, pipe, forging, fitting, bolting based on the different design temperature. So in the first column, different temperature is given, and how you are going to select material, you can select from this table. You can take a photograph of this. Okay. The same like there is another table of temperature versus different form of material selection. External special austenitic steel. So this is also, similar type of PRN number is given over here. Okay. Now we are talking about the high moly steel. High moly means if a moly percentage is 6%. In the austenitic structure, the moly percentage was up to 2.5% of moly. But if you are talking about the more moly, it is called a high moly stainless steel. Now coming to a duplex stainless steel. Duplex, when it is a ferritic and austenitic structure. So its PRI number is generally more than 34 PRI number. So it is given over here. Okay, same way as some ASME, duplex stainless steel property is given over here. Now coming to the medium and high nickel alloy. So it means we are going to add some more nickel, okay, to making it more temperature resistance. Okay. So this is super stainless steel and nickel alloy. In the aero industry, you are going to use the Hastel alloy, Inconel, okay, Inconel. So these are nickel alloy. This is high temperature. Now, in the industry, we are widely using this NORSOC standard. It is an international standard where it gives a guideline how you are going to select which material based on the different system. So when you come to the industry, you need to select the material based on a different international code and standard. So this is a tabular form where you understand how you are going to select the material. Skip this slide. Okay. There are ISO standard also 21457. There is an international standard of organization. They had also a standard for selection of material that also gives some restriction based on the temperature and different uses. So typically you remember that austenitic, if you are talking about the austenitic steel, okay, and we are talking about the offshore environment. Offshore environment means there is a chlorine in the environment, okay, seawater. So it is called marine environment. So temperature, you can use only up to 60 degrees Celsius, this austenitic structure, 316. For 6 moly, 120. If it is a duplex with 22 chrome, it is up to 100 degrees Celsius. If it is 25% chrome, it is up to 110. So, also very important, you see the tabular form. If chromium is increased, it increases the pitting resistance. Okay, nickel is also helping in the pitting resistance. Moly is also helping in the pitting resistance. But suppose you are increasing any selenium or sulfur, okay, then it decreases the pitting resistance. Okay. So we'll take a 2-minute break. 5-minute break, I think, is required. So after that, we will talk about this corrosion and corrosion control. It is okay for you?
Okay, sir. Okay, sir. You can take break, sir, for 5 minutes.
Other can also take break. Yeah.
Okay, sir. Yes, sir.
Okay.
Yes, sir, I agree.
Can we start now?
You can start, sir.
So was talking about this different form of material and type of material. Now, understanding of the corrosion is also important. So the cost of the corrosion in the
Good afternoon, sir.
afternoon, near about 2 to 4%. So why corrosion is important and why we must understand corrosion is important for selection of material. Before going into that, just a very interesting thing that if you are drilling any crude oil or gas from either it is from the earth crust or from the offshore sea, it is not corrosive. It is very good, but it becomes corrosive because of the addition of different type of fluids like produced water, condensate water, water soluble corrosive gases like CO2, S2S, sometimes acetic acid. So in reality, the natural gas, crude oil are not corrosive in nature, but the impurities like water, like CO2, S2S, it makes the crude oil and the gas corrosive. And when it becomes corrosive, you need to control it. Okay, fine. So corrosion is very important because safety of the any plant depends upon the corrosion. Some corrosion is like that. Suppose within a day, it will be the material will be fractured, and there will be no indication of fracture. So it is very important. So corrosion can be defined as a deterioration of destruction of a material through the interaction with its environment. So when the material is being used in a service fluid or in an environment, it is going to deteriorate. So it is termed as a deterioration or destruction of a material through interaction with the environment. So basically there are two types of corrosion, wet and dry corrosion.
Janandar, sir.
Sir, you are mute.
Sir. Hello.
Now it is okay?
Yes, sir. Yes, sir.
I don't know, who is muting me several times. So oxidation and reduction reaction, you must be knowing that suppose two electron is adding it, so oxidation, and if S2S is evaluated, so it is a reduction process. So there are two books, very good book by Fontana, MG, by McCrory, and Cyril LL Corrosion. It is also a very good book. It is an old book. Okay. So typical example, suppose a ship is deep in the ocean, okay? So this part is immersed in the water. So oxidation and reduction process will take place. In the oxidation, what will happen? Two electrons will move, okay? In reduction, what will happen? The OH will be removed. So it forms a rust on the wall. So there is a corrosion. So this is very basic thing. Now, what are the reasons that corrosion is happening? Is I told you water, H2S, CO2, hydrogen chloride, inorganic or organic chlorides. So we must take care of such impurities. In addition of the above, the atmosphere, the cooling water, the sea water are also a very problematic thing for the corrosion. Here you can see here the form of corrosion. It is very explained in the diagram. This is the first one is this one, uniform and general corrosion. You can see here in the left hand side top. In the center, it is called intergranular corrosion. It looks like this. If environmental induced corrosion, it looks like this. If it is a pitting, there are different shape of pitting on the surface. This is called pitting corrosion. Microbiological induced corrosion. Suppose some germ, some insect, other thing are also causing the corrosion in the sea. That is called microbiological induced corrosion. Crevices corrosion. Crevices corrosion means in any of the cavity of any different shape, the corrosion happens because of the stagnant flow. If suppose flow from any body is stuck due to the shape of the material, then there will be chances of crevices corrosion. Like suppose in the condenser tube in the air conditioning, okay, sometime liquid stop there in the some of the tube. That is called crevice corrosion. Galvanic corrosion, because of the potentially different galvanic series, the corrosion happens. So this is a different form of corrosion. So it is categorized as a general and uniform corrosion or galvanic corrosion. Second one, local corrosion means crevices or pitting. Intergranular corrosion is different. Erosion corrosion is different. The stress corrosion cracking is different, and corrosion under insulation is different. And this is very also important. Suppose you are doing insulation on any of the material. So insulation is good for the restricting the heat transfer from one surface to another surface, but also it causing the corrosion. That is called corrosion under insulation. Means if you are going to remove the corrosion from the surface, you will see that there is some pitting and corrosion on the surface of material. So these are classified in a 7 form about this weight corrosion. Okay. Take an idea from this PPT, because in 2 hours you are not going to understand all the materials phenomenon, but you just keep in mind about this term and terminology. Take help from this PPT and different books, recommendations, and you can also reach out to me anytime. General uniform corrosion. You can see in the right hand side picture, this pressure vessel is corroded. It is general corrosion, means rusting all over the surface. It can be cured. It can be encountered by help of the different cathodic protection, or you do the painting or coating on the surface, or you use some innovators. Okay. Galvanic corrosion. You just see here it is a galvanic corrosion. Suppose you are using a stainless steel and carbon steel, or carbon steel and some exotic material having a different series of galvanic, it is going to be corroded. So here it is a simple galvanic series where electron flow from the anodic to the cathodic. The bottom one is anodic nature and top one is cathodic. So if suppose you are using titanium and carbon steel, there will be electron flow. Okay, so carbon steel will be deteriorate. So the positive charge and negative charge difference. So we must understand that we should not use 2 different material all together. Suppose you are using the bolt of different material and nut is different material, and it is very practical example in your house also. Suppose you are using some high grade of steel or copper material for bolting, and you are using a simple carbon steel bolt nut over here, it will be corroded. because of the galvanic series. So such corrosion is called a galvanic corrosion. So yeah, so this need to be taken care. How you are going to take care? Avoid connecting these two different charged material, cathodic and anodic. This is a galvanic series. I mean, it is a diagram of the volt versus SE. Okay, fine. Here in the right hand side, you can see here what we in the industry we are doing is that we are giving an insulating gasket. Insulating gasket, what is happening is able to separate the two different form of material, two different material of different potential difference. So it is happening to not pass the charge from one material to another material. So this is how in industry we are taking care of the galvanic corrosion by installing a insulating gasket. First is do not use it, but suppose it is by virtue you have to use it, then use the insulating gasket. Right? We talked about the crevices corrosion. So basically it is a plate frame heat exchanger where you can see there are different groups. You understand that if the flow is stuck somewhere in the group, of a small group, that is going to be problematic in terms of the crevice corrosion duration over the time. So you must ensure that the path of the fluid, the path of the flow of the fluid in the material is good enough to not make a stagnant flow. Okay. Because you cannot see this corrosion in the equipment. So while designing, it is very important that you are not going to give a very sharp edge or groove that is dangerous for the flow. Okay. How you are going to do the preventing of the crevice corrosion? By different type of non-absorbent gasket made of Teflon. Either you are going to use the butt weld or using the high alloy material. Okay. Leave it. Now pitting. Pitting is basically a localized corrosion that makes hole in a plate or metals. So pitting, if somebody is telling that the material has been pitted, means there is some hole. The hole can be a little hole or big hole, but there will be hole in the material. That is called pitting. You can see in many material in the your house, the tap, water tap, you will see the pitting. Localized corrosion. Localized corrosion looks like this. So how it is affected because of the high chloride concentration or high temperature. Suppose flow is stagnant and very high temperature at one place. So it is going to be affect the stainless steel localized. These are quite used in the industry, that is called intergranular corrosion. Intergranular corrosion is basically a localized grain attack because every material has their different grain size. Suppose there is some reason that is going to attack the grain boundary of any material, that is called intergranular corrosion. Okay. So how it is happening? Corrosion products start to build up in between the long elongated grain, separating them and leading to increase the corrosion propagation to the material. So the grain boundary is helping to not enter the impurities impact on the material. But suppose due to some reason, that grain boundary dislocate and there is a propagation of the corrosion through the grain boundary. That is called intergranular corrosion. This is how you understand. So suppose when the intergranular corrosion is happening, if the chloride content is more, chlorine is very important to understand. If the temperature is high, if the pH is low, if it is more acidic in nature, the intergranular can happen. If it is more chloride in nature, intergranular can happen. So how to prevent? Use the low carbon, reduce the carbon content. It will help to reduce, making a carbide formation. Use a stabilized steel, means use the niobium, titanium adding material, which will help to make a carbide formation, and it will not deplete the chromium and moly from the material. Use the post-weld heat treatment. Means after making the product, you need to do the heat treatment to reduce the stress developed due to the corrosion. This term is, quite interesting. Sensitization. Okay. See, if you are going to sensitize the material, it will help to reduce the intergranule corrosion. How you are going to sensitize the material is by different way of sensitization, by pouring in the liquid and chemical and heating, and then what you call cooling it. So it has to reduce the intergranule corrosion. So certain alloy we have to expose the temperature to the sensitized temperature, okay, and then cool it down. So in the low figure you can see here, the left one is the normalized microstructure, and when you sensitize this, you will just see the grain boundary, how it looks. It good? Looks good. So it will not able to attack the intergranule corrosion. So this is how sensitization help in the intergranule corrosion. There are different methods of doing the sensitization. So I think it will be quite deep in the subject. So I will leave this topic, sensitization. You just Google it, take a help from the book. But I will just give a brief about this. Is that there are three methods of sensitize the material, stainless steel. First is called solution annealing. Means you put the material in the solution, heat up to temperature 1950 to 2050 degree Fahrenheit, and then cool it through the help of water and or air. So this is how high temperature solution annealing. Okay. Another method is called controlled technique of preventing thing. How it is? By adding niobium, titanium. This is called sensitizing elements. So it helps. How it is helping? So niobium and titanium is making carbide. If you are adding this material. If you are not adding this material, what will happen is that chromium will deplete. Okay. Chromium will make a carbide formation and will be chromium carbide. So purpose of chromium was to protect from the corrosion. Now chromium is made the chromium carbide. So the purpose of chromium is totally gone. So to avoid such situation, you have to add some material that is called niobium, titanium. This is called how you are, making a material good. And third option is reduce the carbon content. Sometimes you have to mix all these three methodology to sensitize the stainless steel. Yeah, okay, fine. Now erosion corrosion. Erosion is simple. Suppose you heard about the what you call Robier square. Robier square. Okay, erosional velocity. Okay. So if the velocity of any fluid is quite high and it is impacted on the material, it is going to cause an erosion. Erode it. Okay, erode means it will take out some material from the surface. Okay, so how you are going to avoid the erosion? Avoid the elbow. Okay, elbow means if the flow is taking turn, so there the chances of erosion is more. Okay, fine. This is simple. Now CO2 corrosion. CO2 means carbon dioxide is quite found in the oil and gas field. So it is sweet corrosion and it is corroding the material very fast. How it is making it? It is a concentration of CO2 and like H2S. It is making a oxidation from the material. So you just see here the uniform corrosion and mesa corrosion. Okay, mesa corrosion is the same way CO2 corrosion. There is sometimes called mesa or ringworm corrosion. So basically, CO2 corrosion propagate if the presence of oxygen is more or organic acid. Now coming to the stress corrosion cracking. Suppose you are working on any material. Okay. and it exposed to some environment. So the stress developed by the working and also due to the environment makes a stress corrosion cracking. So it develop a tensile strength on the material all time. So you have to relieve those stresses from the material by using of heat treatment, different methodology. Okay. So this is one table that it will tell that carbon steel is good for hydroxide, carbonate like this. So how stress corrosion cracking happens? First stage is crack initiation. At some point of the time in the material, there is a simple crack. In the second stage, it will steady propagation of the crack. The simple crack will crack a little more. And third stage is final failure. Means it will be totally propagate and material will fail. So there is a good book by Russell at Jones. You can go through that and you will get an idea about the stress corrosion cracking. Now there is another term, chloride stress cracking. Okay, sulfur stress cracking, chloride stress cracking. So when I'm talking about the stress cracking, you understand there is a stress developed on the material by which fluid or chemical, that is chloride. If it is chloride, it is called chloride stress cracking. If suppose you are using a material in the chloride environment, it can develop a chloride stress cracking. Okay. So you can see here, oxygen corrosion and the pitting with the chloride. So as I told you, stress is still in the marine environment. Marine environment contains the chloride. So you need to restrict up to 60 degrees Celsius. Now sulfide stress cracking due to the S2S. So if it is it is form of a hydrogen embrittlement, which is a cathodic cracking mechanism. So do not confuse between the stress corrosion cracking and anodic cracking mechanism. So anodic cracking mechanism is different, and the stress corrosion cracking is an anodic one, but the sulfide stress cracking is a cathodic cracking. So there are two types of cracking, anodic and cathodic. Sulfide is a cathodic and stress corrosion is a anodic. So it is basically a hydrogen embrittlement. Hydrogen gas, comes in the material and it propagates the cracks in the material. Now sulfide stress cracking. There is an international code and standard NACE MR 0175 and for the offshore. So it gives a guideline how to use the material, what are the properties that material should be if you are using for the S2S service. Okay, so there are some guidelines. Okay. How you are going to reduce or prevent the sulfide stress cracking? By reduce the stress level, by reducing the hardness level, by using the PWST, avoid the hydrogen source. Okay. So NACE is the National Association of Corrosion Engineer, which gives a guideline. I will not go through the source service requirement. These are some industry terms. Okay. Effect of hydrogen. Okay. Presence of hydrogen in the steel is sometimes making a problem because it helps in propagating the corrosion. So hydrogen is always present in the atmosphere, or even in the welded surface, or even in the electrode flux. So when you are doing welding or something, so hydrogen can be at the weld surface or the material surface, and it affects the corrosion by attacking on the surface of the material. So hydrogen is very much dangerous for the material. So how it happens, hydrogen cracking, you can see there's a bubble. Hydrogen is induced inside the material. Hydrogen अंदर चला जा चुका है इस material के अंदर, है ना? So this is called hydrogen induced cracking. This is a cold cracking. Okay. It can be happen during the manufacturing or during fabrication or in service also. Okay. I will not explain about the bleaching and HIC. So I will leave this. Just remember this term, hydrogen-induced cracking. Another term is hydrogen embrittlement. Okay. So it is basically a mechanical damage of a material caused due to the presence of hydrogen. Okay. So this is how the hydrogen embrittlement helps. It losing the ductility means brittleness will be increased. Means hardness will be more. So material will be embrittled. So that is called hydrogen embrittlement. Source service corrosion mitigation. How we are going to do the mitigation of the corrosion is first is called hardness control. You have to control the hardness, means you are making it more, brittleness free material. Killed carbon steel means oxygen is removed, fully killed carbon steel. HIC resistance, hydrogen induced cracking resistance material. Sulfur concentration you have to reduce it. You make it the material as a normalized and do the post-filter treatment. So these are simple source service requirements. Another corrosion is corrosion under insulation. I told you about the corrosion under insulation. If you are doing the insulation on the material without painting, the corrosion will be there because of the moisture present on the surface of the material. Biological corrosion due to the certain living organism is contact with the metal causes the corrosion rates. So this is called biological. So in the offshore, in the sea, this is very much important. A very interesting term, selective bleaching. Selective bleaching means sometimes you will see in the photographs that some part of the material is corroded, but some part is not corroded. That is called selective bleaching. Okay, some part will be corroded and some part looks like a new one. So this is called selective bleaching, means removal of particular material or the surface from the some area, not from the all level. Okay, so example are dezincinification of the brass and denickelification in the copper nickel alloys water system. So selective bleaching names terms in the particular area, corrosion will be there. So question is, we learn about the corrosion. Corrosion is very important. There are different type of corrosion. Wet corrosion we learn. Dry corrosion I have not explained because it is dependent on the temperature and oxygen removal. Okay. So how we are going to combat? How we are going to prevent the corrosion? So there are three simple methodology. One, either change the material because you know which material is suitable for which service, or reduce the intensity of the corrosion attack. How? By adding some chemical in the fluid. Okay, suppose you are going to add some chemical and increase its pH value, so it will be more, it will be less acidic in nature, or remove oxygen from the fluid. So these are some technique you can reduce the corrosive media nature. Or third, make a barrier layer. Barrier layer means by doing some painting, by using some gasket, insulating gaskets. So these are the three methodology, simple methodology that all industry and everywhere it is being taken care to combat the corrosion. So this is some in last few slides. You will have a general guideline about how we are using which material for which purpose. Okay? Take a photograph of this. This is very good consolidation of oil and gas application, hydrocarbon industry. So when we are using carbon, magnesium, silicon steel, when we are using the straight chrome steel, when we are using the nickel and duplex, so likewise. Okay. So I'll explain you about the change in the corrosive material medium by adding some chemical like corrosion inhibitors, scale inhibitors, oxygen exchanger, other chemicals. Intermediate barrier. So intermediate barrier is you are doing a coating or painting on your car, on your bike, on your home. Why it is so? To give a layer of barrier of corrosion attack on the parent material. So remember, corrosion is very important. So with this, I will end the today's session. I'll accelerate the presentation because it was about 1 to 2 slides. But hope you heard about some terminology, uh, different grade of material, shape of material. So do a study from different books, material science book, metallurgy book, and some industrial guideline, standard and code in the standard. So I'm ready to take any question.
Participant, if you have any question, then you may ask. कौन चला देगा इस आंसर? Participant, if you have any question, then you may ask.
Okay, Mr. Bennett, they are hesitating to ask any question. Huh?
सर आवाज फ्रेश नहीं आ रहा है.
Press नहीं आ रहा है?
Have you any question? Hello.
I will randomly ask from a few of the candidates. Arbaz Khan, Aryant Kumar.
Arbaz Khan, Deepak Raj, if you have any question, then you may ask.
Anju Kumari, Ankit Kumar, Ankur Dikshit, Arpana Sukla. So, I mean, many participants are there.
Yes, sir. Yes, sir. So thank you, sir. Sir, actually, thank you, sir. Giving such a nice and session was very, very nice and informative session. So, sir, you have discussed different type of material and its application in oil and gas industries, and even if you have discussed different type of corrosion, that means wet corrosion, and there are so many stress corrosion cracking, erosion corrosion, and chloride stress corrosion, sulfide stress corrosion. So you have discussed so many terms, so our students will be benefited after learning this all topic. So very, very nice topic, sir. Janandar, sir.
Yeah, thank you.
Very, very thank you, sir, giving your precious time to make to make this short-term training program for successful.
Yeah.
Sir, you have given nice time, sir, for presentation.
Thank you so much for your valuable time, and go through the slides that I have given. If you have any question, give an what you call chat box. Thank you.
Hello. वहाँ भी देखो कुछ चला रहा है, कुछ डांस से कुछ चला रहा है। कौन कर रहा है ये? बार 2 बार हो गया यार, समझ रहे? पूरा चला दे रहा है। हेलो हेलो
नहीं कुछ नहीं बोले। यस सर।
हेलो। So next session will be started 5 p.m. onward.
नहीं हेलो मातो जी हेलो।
हाँ संदीप सर।
440
Okay, so dear participant, your next session will be started from 4:40 p.m. onward.
यस सर।
लिंक गूगल मीट प्रीवियस लिंक।
Okay, so all of you have to join through previous Google Meet link. This link was applicable for this particular session. So next session onward, you have to use previous link.
But do we have to leave now?
Yes, you can leave.
Excuse me, sir. The link which is provided before, we have to use that, right?
Yes, sir. Yes, you can join through this link, this previous link.
Okay. Okay. Thank you, sir. Thank you, sir.
Welcome.
सेशन वाइंड अप हो गया क्या? वैलिडेट हो गया?
आवेश